This video is about how to use the spreadsheet to sort your cubes to decide what are usable parts and what are not usable parts. I've entered all of my raw data. Now I've got my formulas all input over here under statistic name. So I'm going to highlight all the data. I'm going to right click. I'm going to copy that. I'm going to go to sorted data. I'm going to right click and paste that data. I'm going to push escape a couple times, well, just once, to get rid of the highlighting over here under raw data. Now, where it says sorted data, I'm going to right click, go down to the word sort, and click on smallest to largest. And when I do that, all my statistical data comes in here for my mean, my median, my mode, my range, and the important one here, which is standard deviation. Now, standard deviation is a measure of how much the cubes can vary from the statistical mean, which is a bell curve. What we're going to do is we are going to take any cube that has a size within 2 standard deviations. So we're just going to go to the third decimal place here. That means that any cube that is, here's our mean, which is 0.75. So any cube that is 0.75 plus 0.006 times 2. So in other words, 12 thousandths. So it's 0.750 plus 12 thousandths, which would be 0.762, and 0.750 minus 12 thousandths, which would be 738. So anything that is, here we'll put a formula in, equals this one plus, oops, backspace, I use the plus sign, plus, I'm going to put in a parentheses, this one times 2, close parentheses, and I think this will work. So anything that is, well, 763. So I'm going to just write largest here. And then we're going to do another formula, equals this minus, and then parentheses, the standard deviation times 2, close parentheses, equals. So anything, any cube that is 0.737 to 0.763, we're going to keep. I'm going to write smallest down here. So we'll keep those cubes. So let's see, in our sorted data, we have 763 is our largest. So we have only one, it's cube number 27, that's 0.77. I'm going to find cube 27 in my package of cubes, and I'm going to trade that one in and get another cube that measures between these two numbers. And then our smallest is 0.737. So there are no cubes that are too small in this package of cubes. So I have to just get one cube traded in. Now, when you go to assemble your puzzle cubes, you're going to want to make sure that when you have pieces that slide together, that you use a cube that's a larger cube. So for instance, if I had two interlocking pieces, the piece 0.761 in length, which is cube number 26, I would use that one as the piece that's the spacer. And then the piece that fits into it, I would probably use one of the smaller cubes to fit them together. We don't want to have to do a lot of sanding when we put our cubes together. So that's how we're going to try to use our statistical data to calculate the smallest and largest sizes of our puzzle cubes.